Data engineers can earn around $190,000 per year in 2026. That is the upper bracket number that attracts attention. But most professionals entering data engineering will not start anywhere near that range. The ceiling is high. The path is technical. And the competition is more layered than many expect. This is the full breakdown, salary breakdown. At the entry level, data engineers typically earn between $85,000 and $115,000 per year in the United States. The range depends on SQL depth, cloud experience, and familiarity with distributed systems. Entry roles often involve maintaining pipelines, cleaning data flows, and supporting analytics teams. Early compensation reflects operational trust. The more critical the data system, the more cautious companies become with junior autonomy. Mid-level data engineers usually fall into the $125,000 to $160,000 range. At this stage, engineers design and optimize data pipelines, manage ETL workflows, build scalable storage solutions, and collaborate closely with data scientists and back-end teams. Compensation increases because reliability and scalability directly impact business intelligence and executive decision-making. When dashboards fail, leadership feels it immediately. Senior data engineers can reach $170,000 to $190,000 or more, particularly in companies where data infrastructure drives revenue. These engineers architect large-scale data systems, manage distributed processing frameworks, optimize performance under heavy load, and ensure data quality across multiple environments. The salary ceiling reflects architectural responsibility and production impact. Market demand. Data remains central to business strategy in 2026. Organizations rely on real-time analytics, predictive modeling, operational dashboards, personalization systems, and automation engines to guide decisions. None of those systems function without stable data infrastructure. Data engineers sit at the foundation of that ecosystem. Data infrastructure complexity is increasing, not decreasing. As organizations integrate machine learning systems, streaming pipelines, and automated reporting layers, the tolerance for data failure drops significantly. A broken pipeline is no longer an inconvenience. It can directly affect revenue, customer experience, compliance reporting, and operational visibility. That dependency increases the strategic importance of experienced data engineers. At the same time, companies are consolidating tooling. Instead of fragmented analytics stacks, many prefer unified cloud data platforms that combine storage, orchestration, and monitoring. Engineers who understand how to integrate those components into a coherent and cost-efficient system gain disproportionate leverage in hiring discussions. However, hiring standards have risen. Employers expect experience with cloud data warehouses, orchestration frameworks, distributed storage systems, and performance optimization techniques. Surface-level SQL knowledge is no longer sufficient for competitive roles. The market rewards engineers who understand scale. Competition level. Data engineering sits between software engineering and data science. That hybrid positioning increases competition from both sides. Software developers may transition toward data infrastructure. Data analysts may attempt to upskill into engineering roles. That crossover increases applicant volume. The skill threshold is technical. Strong SQL, Python proficiency, distributed systems awareness, and cloud platform experience are typically required. Employers look for candidates who can manage scale and prevent data failures that disrupt decision-making pipelines. Real-world production exposure carries more weight than theoretical familiarity. Junior reality. Breaking into data engineering often requires prior exposure to back-end development, analytics engineering, or database administration. Pure entry-level data engineering roles are less common than many assume. Many professionals transition into data engineering rather than starting there directly. Junior engineers frequently begin by maintaining existing pipelines, monitoring data flows, troubleshooting failed jobs, validating transformations, and supporting reporting teams. Growth depends on demonstrating reliability, reducing downtime, and improving pipeline performance. Promotions are usually tied to measurable stability improvements. Long-term outlook. Data volume continues expanding across industries. Automation systems, AI models, operational monitoring platforms, and real-time personalization engines all depend on structured and reliable data infrastructure. That structural reliance supports long-term demand for data engineers. The most valuable engineers understand not only how to move data, but how to optimize cost and performance. As cloud spending becomes a major operational expense, efficiency in data architecture becomes financially significant. Engineers who design systems that scale predictably without inflating compute costs strengthen their long-term leverage. Positioning strategy. If your goal is to approach the $190,000 range, depth matters. Master distributed processing frameworks. Understand partitioning strategies and indexing design. Learn how to build fault-tolerant pipelines that recover gracefully from failure. Develop strong knowledge of cloud storage tiers and compute optimization models. Another differentiator in 2026 is performance optimization expertise. As data volumes scale, inefficient queries and poorly designed pipelines become expensive. Engineers who can reduce compute costs while maintaining reliability become financially impactful. That impact is measurable. Measurable impact strengthens compensation leverage. In practical terms, this means thinking beyond code correctness. It means focusing on throughput, latency, storage efficiency, and recovery time objectives. Data engineers who operate at that systems level move faster toward the upper salary brackets. Risk and resilience. Data engineering roles are resilient because they support core reporting, analytics, and operational systems. However, tooling evolves quickly. Engineers who rely solely on one vendor ecosystem risk stagnation. Adaptability across platforms strengthens long-term stability. Resilience in this field comes from understanding fundamentals of distributed storage, data modeling, and system design, rather than memorizing specific tools. Final verdict. Data engineering in 2026 can reach $190,000 and beyond, but that outcome reflects specialization, scalability expertise, and consistent performance under production pressure. Entry is competitive. Mid-level growth requires technical depth. Senior compensation demands architectural impact. The salary potential is real. The infrastructure complexity is real. The competition is real. For engineers who enjoy building the backbone of data-driven systems, data engineering remains one of the strongest high-income technical paths available today.